Tech Effect.
Welcome to Tech Effect, a monthly podcast series brought to you by TestDevLab. I'm Adrian, the host of the podcast, and together with industry experts, we provide discussions and advanced insights about trending topics in software engineering. Don't miss out on new episodes, and let's keep advancing our skills and knowledge set.
Welcome to the first podcast of this year for the Tech Effect series. Today we'll be diving into the exciting world of Bluetooth technology. In a time where wireless communication is actually a huge part of our lives, getting the Bluetooth codec is really important. So I'm thrilled to say that we have a special guest today in this podcast series from TestDevLab, Esam Ali-Halil. He's an automation engineer with quite rich background actually in sound engineering. He brings a lot of wealth of knowledge from his experience at TDL and also as a former sound and TV communication engineer for national TV. And that all is topped with a degree in sound engineering from London University. So yeah, welcome to the podcast, Esam. How are you doing?
I'm all right. I'm still alive. Excited to be here. Excited to share whatever I know.
So you're excited to actually get good questions and teach us about the Bluetooth codecs, right?
Yes, well, I like talking. I like technology, and Bluetooth is a part of my life, everybody's life at this point. So it will be an interesting thing to talk about.
How did you end up actually going for the Bluetooth side?
Well, for me, it was a couple of years ago, a big experience of understanding like, hey, there is a big difference between wired connection in terms of the quality of the audio and wireless connection. And I realized that not a lot of people actually know this. And when talking to some of my colleagues, I realized that even some tech-savvy people do not have the extensive knowledge of what Bluetooth codecs are, how they function, and what is the difference between wireless and wired. So I decided that maybe we can discuss this, and then some people might use this information in testing.
Okay. Interesting. Can you maybe explain in a simple terms what Bluetooth codec is?
Yeah, sure. So basically, a Bluetooth codec is a piece of software or an algorithm that is used to encode and decode digital audio data. So it's an essential part of how Bluetooth devices communicate audio wirelessly. So when you play music on your smartphone and listen to it through, for example, Bluetooth headphones or a Bluetooth speaker, the audio data needs to be transmitted over air. So this data is usually too large to send in its original form. So a codec basically compresses it to make it smaller and more manageable for wireless transmission. So once the compressed audio data reaches your Bluetooth headphones or the speaker, the codec decompresses it, turning it back into high-quality audio that you can hear. So there's different codecs, and they all vary in how efficiently they compress and decompress audio. We'll dive into the separate, like what kind of codecs there are a little bit later. And all of that can affect the sound quality and the latency. So latency is the delay between the moment in time where the signal is sent out and received by the destination device. So again, there are several types of these Bluetooth codecs, and each have their own strengths and weaknesses, and each have their use cases. So for example, some of them are optimized for high quality audio, while others prioritize stable connectivity for low latency latencycy
So there are some companies that prioritize low latency, some companies that prioritize low latency, some prioritize actually a stable connection, right?
It's not more about companies, it's types of Bluetooth codecs themselves. So for example, there is a type of Bluetooth codecs called the aptX. Those are developed by Qualcomm, and they have a whole family. So there's aptX family, there's aptX, the standard one, there's aptX HD, and there's aptX low latency. So if you compare it to the basic codec, which is the SBC codec, that's the sub-band codec, it's a mandatory codec that all Bluetooth devices support. It is the lowest quality codec, but it's the most available one. The aptX is a level above. So it can transmit more data, so more audio information. So if we're talking about the aptX HD. And then there's aptX low latency. So it might not transfer as much audio data as the HD one, but is going to do it faster. So the latency is going to be smaller.
Yeah, I have actually seen that aptX Qualcomm thing when I had my Android phone.
Yeah.
When you turn on the Bluetooth, some of them had this like a pop-up notification. Hey, this is supported by this, and you have
Yeah.
better quality. And then actually, I recall that they had even a sound equalizer where you could improve the sound.
Yeah. Well, sound equalizer usually does not necessarily improve the sound, but you can shape the sound signature of the headphones. Yeah.
And as there are different bands as well, right, for the Bluetooth technology, right?
Well, there's a band in terms of what frequency it occupies. It would be the 2.4 gigahertz band. And I think it uses, so from 2.4 gigahertz to 2.480 gigahertz. So that's 80 bands of 1 hertz difference. So usually Bluetooth uses one of them. As far as I understand, the reasons behind choosing the 2.4 gigahertz band, there are several of them. So first of all, the global availability. So the 2.4 gigahertz band is globally unlicensed. So that means that it is available for use in most countries without the need for a license, first of all. So this makes Bluetooth universally applicable and reduces complexities related to, for example, international regulatory compliance, that sort of thing. So the next thing is also that you need to know about the 2.4 gigahertz band is that it is also used by many other devices and technologies. So that includes Wi-Fi, microwave ovens, cordless phones, and even some medical equipment. So all of them create this crowded environment, which can lead to interference, where signals from different devices disrupt each other. So to mitigate that, Bluetooth uses things like frequency hopping or low power signals to minimize the interference. So frequency hopping is the thing that I mentioned, that you have these increments of 1 megahertz in the bandwidth of like 80 megahertz that Bluetooth occupies that space. And if some of them have interference, it's going to choose the less crowded one. And then low power signals basically, well, it's like when you have a high-powered signal anywhere, it is going to disrupt everything. So it's going to disrupt all of the low-powered signals and is going to affect the transmission. So Bluetooth uses low-power signals to minimize this interference with each other. Then there's also a thing where 2.4 gigahertz band provides a very good balance between range and power consumption. So it offers enough range for typical use cases like connecting a smartphone to headphones, for example, or a speaker, while also being power efficient enough for small battery-powered devices. So if we would have a less power-efficient technology, it would drain the battery really quick, because Bluetooth is usually installed on devices that are battery-powered. So there's also, or you wanted to ask a question?
Can, for example, 2.4 gigahertz frequency band be actually used like in smart home environments as well?
Yeah. As far as I understand, it's sort of emerging technology. Probably some of it is already integrated, but as far as I understand, we're going to be seeing a lot more of Bluetooth technology integrated into the Internet of Things, exactly like smart homes.
If there are like a lot of devices and a home with 2.4 gigahertz frequency, right? Is there problems with interfering? For example, if you have like 10 devices versus like 30 devices and they all have the Bluetooth on or connecting to each other, will there be like some issues with the frequencies?
There might be, but I guess it very depends on what kind of devices those are. So it's very dependent on, for example, the strength of the signal, the manufacturer, what kind of device that is. So it's maybe 30 devices of X configuration might act completely different than the 30 devices of Y configuration. You have to look at the exact use case, what is happening there.
Okay, and how about bandwidth constraints? For example, does it influence the development and performance somehow of these Bluetooth codecs?
Yes, it does. So first of all, what you need to understand is there's a compression necessity when we're talking about how it influences development. So but limited bandwidth means that audio data must be compressed to be transmitted efficiently over Bluetooth. So codecs are designed to compress audio data into smaller sizes, as I said before, to fit the available bandwidth. So the more effective the compression, the better the performance within these bandwidth limits will be. So that has to be taken into account when developing those Bluetooth codecs. So there's also a trade-off when compressing the audio. So higher compression can lead to lower audio quality because when it is compressed, some data is lost or it's just simplified in the process. So codecs also must be designed and developed to balance the need for small data size to fit within those bandwidth constraints with the desire for high fidelity audio. So this is an ongoing thing.
What role does the bitrate play in the Bluetooth audio quality?
Yeah, it's a good question. So first of all, we need to talk about the definition of bitrate. So bitrate is the amount of audio data that is transferred per unit of time. So usually it's measured in kilobits per second, or kbps. You've probably seen that abbreviation somewhere. So in the context of Bluetooth audio, it's a measure of how much audio information is sent from the source, like smartphone, to receiving device like headphones or speakers. So generally, a higher bit rate allows for higher audio quality. So this is because more data per second is sent, so that means there's more detail in the sound reproduction. So when a codec uses a higher bit rate, it can deliver audio that is closer to the original recording with better clarity and depth. There's also one thing that we need to talk about is, again, compression and loss of detail. So Bluetooth audio requires compression to reduce the size of the audio files for wireless transmission. So higher bitrate codecs can afford less compression, which means less loss in detail, and then again, a richer, more accurate sound. So those would be codecs like the aptX HD, LDAC. This is a Sony proprietary codec. And then there's also, I think it's called LDHC. So basically, the LDAC is probably the best codec, the best Bluetooth codec available in terms of the detail that it can provide. But still, it's lossy, so it's not giving you the full image of what you hear. So there's also this thing called perceptual coding. So modern codecs use advanced techniques like perceptual coding to maximize audio quality at a given bitrate. So this is basically a way to compress audio by removing parts of the sound that are less likely to be noticed by human ear. So this allows for better quality at lower bit rates. We're just getting rid of information that is less likely to be perceived by humans. So this is a very important part because sometimes objective results or like analysis of a spectrogram is not very representative of what we hear. It might show like there's a lot of errors or there's a lot of artifacts. It looks very bad. But when you listen to the recording, it's not actually affecting the areas that you might find important. Like I've noticed that.
This perceptual coding, it's like in all the codecs, right?
Some of them. As far as I understand, it's the more advanced codecs.
Okay,
So-
and does it, for example, impact the battery life on Bluetooth-enabled devices as well, or it's just are there some trade-offs for that between the audio quality and data compression as well?
Yes. So when we're talking about Bluetooth codecs, like for example, let's take LDAC because it's the highest tier one, is going to transfer a lot of data. So it's going to take up the processing power and the transmitting power of the phone. So that is going to drain the battery quicker. Of course, now there are I guess. I wouldn't say emerging technologies. I think they're still working on the same codecs, just updating them. So they are becoming more power efficient. But still, if you want to transfer more data, you need more energy, and you can't really get around that.
Okay, that was a great explanation. If we're talking about the bitrate,
Yes.
What role does it play? For example, explain it in simple terms. What role does the bitrate play in the Bluetooth audio quality?
So bitrate basically gives you an amount of information per a set amount of time. So again, it's measured in kilobits per second, and the higher the bitrate is, so the higher the kilobits per second is, the more you have information per for example, during 1 second. So the less bitrate is, you'll hear that there's missing low end, so low frequencies start to disappear, high frequencies start to disappear until we get into this kind of when you talk on a phone or you talk on a Bluetooth headset that somebody calls you and your music suddenly shuts off and you're hearing in a very, very bad quality. So this is a mode for like headphones, and I guess I actually don't know if they're using a different Bluetooth codec, probably the same, but it just cuts off the unnecessary high end and low end. So the kilobit per second drops significantly for you to only hear the voice, because the human hearing is most perceptive at the middle frequency, so around 4 kilohertz. So that's why the kilobit per second drops to, I don't know the exact numbers, but it definitely drops significantly because you can hear deterioration in the audio. And then you can only hear the voice while you're talking on the phone. So that would be an example of how, for example, bitrate drops and you can hear the deterioration of the sound itself.
Can you maybe explain also about the concept of sampling rate and how it is important inside the Bluetooth?
This one's interesting because I couldn't get my head around it for the longest time, although I was already working in television, but I was like, what is this? What do you mean by sampling? What is this sample? So sampling rate, by definition, is basically, first of all, it's measured in hertz, and it's the number of times per second that audio is sampled when it's converted from an analog signal, so like a sound wave, to a digital signal. So essentially, it's how often the audio signal is measured. So when the audio is recorded, the continuous analog sound wave, you've probably seen, it's like let's just imagine a sine wave. So it's continuous. And then it's converted into a digital format. So it's done by taking regular samples of the audio wave at fixed intervals. So the sampling rate determines how many of these samples are taken per second. So for instance, we have a regular sampling rate of 44.1 kilohertz, which means that the audio is sampled 44,100 times per second. So you can imagine, for example, a sound wave, and if you zoom in into a section of the sound wave, you'll see like these dots, and each dot is a sample which represents the certain frequency and amplitude in this given time. So sampling rate also directly impacts the quality of audio. So higher sampling rates can capture more detail from the, for example, original analog sound wave, leading to a more accurate and higher quality digital representation of that analog sound wave. This is because a higher sampling rate can capture more of the nuances and the frequencies in the sound wave. Also, there is this thing that is called the Nyquist theorem. I've studied it. I stumbled upon it recently, and I remember, I studied this in university. So basically, what this says, according to the Nyquist theorem, the sampling rate should be at least twice the highest frequency you want to capture. So, for example, human hearing gives out at around 20 kilohertz. So, sampling rate of 40 kilohertz would be the minimum to accurately capture the audible frequency. So, for example, most CDs, for instance, have a sampling rate of 44.1 kilohertz, which is slightly above the minimum. If we're talking about Bluetooth, sampling rate is key in determining the quality of the sound that's transmitted wirelessly. So the codec used for the Bluetooth connection will dictate the maximum sampling rate that can be supported. So higher quality codecs can support higher sampling rates, leading to sound quality. But also, how should I put it? There are always trade-offs, because Yeah, go on, please.
So to understand correctly, higher sampling rate can provide a better audio quality,
Yes.
but it probably requires more bandwidth and more
Yes,
power,
exactly.
right?
Exactly. That is the trade-off. So also, how should I put it? From what I remember, going above 44.1 kilohertz sampling rate is not very it's point of diminishing returns. So you will not hear a massive difference, especially when you're listening on your everyday like driver headphones or your phone. But there's going to be more delay, so latency. There's going to be artifacts. It's going to the power consumption is going to increase. And like if we're talking about listening to things on Bluetooth, where do people usually listen to things now from? It's Spotify. Spotify has poor quality. Like it sounds all right, but once you listen to something on a high fidelity system and without compression, you realize how bad Spotify sounds. You just used to it. I'm used to it as well. I've used many streaming services. Tidal, these are the ones that have the they brand themselves as lossless, but they're not. Just higher quality. And then when you return to Spotify, you're like, yeah, there's a lot of information missing. So again, yeah, going above, yeah.
But can you improve that by having a better earphones, for example? Or
No.
or still, if Spotify has this less quality, it will still be. Well, for example, you have high-end equipment on your head, it still won't produce better result because Spotify just outputs the sampling rate that it outputs, right?
It's not even about sampling rates. It's more about the kilobits per second. So the bandwidth here. Yeah, it's going to be limited by the source. So of course, if you have better audio equipment, there's going to be some improvements. There's going to be a bigger stereo image, or there's just better like low end response, or just the signature of your audio equipment is going to make it sound better. But in reality, if even you're listening to it wired, so there's no loss in the information in the audio data, the maximum amount of kilobits per second that Spotify outputs is 320. That's MP3. So even when we're talking about CD quality, that's 4 times as more. CD quality is 1,411 kilobits per second. So, and also there's this interesting misconception about Bluetooth being like how to differentiate from lossless Bluetooth and lossy Bluetooth. All Bluetooth codecs are lossy. There is no such thing as lossless Bluetooth. As much as the marketing teams of all these companies want you to believe in that, it's not happening. So because we can, let's juxtapose the best Bluetooth codec available now. So it's Sony proprietary codec, LDAC. It can transfer up to 960 kilobits per second, if I'm not mistaken. It does have the sampling rate possibility of 96 kilohertz. But for example, if we take the CD quality, so it's going to be 1,411 kilobits per second. So the highest codec is basically worse than just the CD quality. And if we're talking about like audiophiles and people who listen to things in, for example, there's Bluetooth codecs and there's codecs that are used for storing audio data. So that's MP3, there's WAV, and then there's FLAC and LAC. But FLAC, being the master race of it, it can hold information. So the bandwidth the bit rate of FLAC is the maximum of 36,000 kilobits per second. So if we compare it to, for example, the SBC codec, that's 100 times more. So that's 2 orders of magnitude more. So basically, whatever they say about Bluetooth, yeah, it can get good for whatever you're using if it's just, your daily driver, but it's not as nearly as good as wired connections, and it's not lossless by any definition.
I recall that, for example, in gaming, everyone uses actually wired connections, right? And
yes,
that probably is linked towards the latency, right?
Yes, exactly.
So from that, I'm just thinking about why, for example, latency is actually crucial? Why is latency a crucial factor in Bluetooth audio, especially if we, for example, take gaming or streaming?
Yeah. So with latency the thing is that it is important, first of all, for audio-visual synchronization. So in gaming or when watching videos, the synchronization between audio and visual elements is essential. So high latency can lead to a very noticeable delay between the video you see and the audio you hear, making it really unpleasant and disruptive, especially if we're talking about gaming experiences. So for gamers, latency is critical. So there's fast-paced games, and even a slight delay in audio can affect the gameplay, or you can just, all of your teammates are going to die, and then you're going to hear a lot of nice things about yourself.
Especially in Counter-Strike, you need to have that low latency possibility. So
exactly.
That's true.
So sound cues are often crucial for timely reactions, especially in competitive gaming. So then there's also, in terms of real-time communication, in streaming and video conferencing, high latency can disrupt the flow of conversation, making it difficult to communicate effectively in real time. So it happens all the time when people start talking over each other, because it takes time for the voice of your dialogue partner to come to you. Then you have to, it takes time, and so it starts overlapping. So also latency the is usually measured in milliseconds. So it represents, again, the time delay from the moment the audio signal is sent and the source device receives it. So there is also several points I want to make about the acceptable levels of latency depending on the use cases. So if we're talking about like audio listening, music or podcasts, a higher latency, so up to 150 to 100 milliseconds might be acceptable, as in synchronization with visual content is not critical. But I would argue that with music, it's probably even more, because you have nothing to synchronize. You can sacrifice that latency in order to gain more definition when listening to that music. So in terms of video streaming, a latency below 100 milliseconds is often considered acceptable, so as it keeps the audio and video sufficiently synchronized for most viewers. And again, for gaming and real-time interaction, lower latency latency is desirable, so ideally even below 40 milliseconds. So some specialized low-latency latency the Bluetooth codecs, like, for example, the aptX low latency, it's just called like that, aim to achieve this with even lower figures, but like those are these specific use cases. From my own personal experience, I can say that I've also tried to produce music with Bluetooth headphones, and I've encountered the issue where the latency was really not that good. It was even more. So I would say it was almost up to a second. And like it disrupted the flow so bad, because when you're writing music, you want it to be responsive. Like you move this, you start playing from this part, and then it goes on. But when you hit play, there's like the image starts moving. It's like it's playing, and then the sound comes in, and it's like it's so disorientating. It's unbelievable. Yeah.
And for example, you're saying that there's like these problems of latency in Bluetooth audio, right?
Yes.
How, for example, they can be mitigated?
So mitigation of latency I would say would be choosing the right Bluetooth codec for it. So for example, go on.
I'm just thinking you're choosing the right codec, right? So
yes,
if I have like AirPods, right?
Yes.
Is it possible to switch the codec that they're using?
AirPods, as far as I know, since they're a part of Apple ecosystem, they are using the AAC, so that's Advanced Audio Codec, and the in the case of Apple, for example, this use case, I believe it dynamically adjusts and adapts the latency and the bit rate. So depending on what you're doing, so obviously they have like AI and machine learning in your phone, and probably, I don't know if that does it, but as far as I understand, it dynamically adjusts depending on what you do at this point in time. So when we're talking about Androids or devices that support multiple codecs, I believe that there's switching between the codecs. So it chooses the correct codec for example, best quality or like the lowest latency and so on.
So let's turn to mitigating. You said to mitigate some of the risks of latency, you need to choose the correct codec. How
Yes.
do I know when and how do I need to change the codec, if I can?
It's done automatically. From my understanding, it's done automatically. So you don't have to change anything. You can do it manually. You can go into your phone and change it. But most of the times, like, either it's done automatically, or if it's an advanced codec, I'm not sure which one of those support, but I would make an educated guess that the higher tier ones, they support this adaptive bitrate or adaptive switch between the high latency or low latency, depending on what is going on. But that's a good question. Like, I have not looked into this. Might want to check this out. But for example, if we're talking about also mitigation, there's things like code processing, Bluetooth version, buffering size, and the transmission distance. So if we're talking about not code processing, codec processing. So the time it takes for the codec to encode and decode audio data, it introduces latency. So high complexity codecs might offer better sound quality, but then again, they add more delay. So here, the aptX low latency and the AAC come in, which can reduce the processing time. Then there's also something that you have to take into account is the Bluetooth versions. So we're most likely using the Bluetooth 5.0. And these the 5.0 version is optimized for faster data transmission. If for some reason you have a device that uses an older Bluetooth version, they might not be as efficient in handling data. And that can also lead to higher latency. So using the latest updates, the latest Bluetooth versions here would be very important. Then there's also a thing called buffering. So audio data is often buffered or temporarily stored at various stages to ensure smooth playback. So you can find it even in video when you're watching a video on YouTube, and you can see that it's loading a little bit more.
Yeah, in offline mode, you have actually buffering, and there's in Netflix it has buffering. So in a lot of different offline video streaming places.
Yeah, well, that is done to give you a smoother playback. So there's no freezes, there's no glitches and whatnot. So if there's an option like that, you can reduce the buffer size to decrease the latency. But I've done it with, for example, I work in Ableton. This is the digital audio workstation of my choice. And you can manage the buffer size in terms of like how much you want of the load on your PC, how well it can handle it. So you can like play around and choose the exact buffer size for you to, acceptable latency and no glitches. And so basically larger buffers can add to the delay. So you will have to, if you have this option, you can reduce the buffer size to a point. For example, you reduce it to a point where you start getting glitches, and then you raise it a little bit. And then you'll be right at the threshold of that perfect balance between the latency and the sound quality. So that's one of the things as well. And last but not least, transmission distance. So distance between Bluetooth source and the receiver, that also can affect latency. So greater distances can lead to delays in data transmission. And also if there's like obstacles that can cause, for example, packet loss, or I actually don't know what it's probably not called packet loss. It's like, let's just say audio data loss. And then things like error correction will have to kick in and to compensate for that.
Yeah. Can you do a quick recap of how the different compression methods affect sound quality on a higher level?
So on the higher level, I would say that the more kilobits per second the Bluetooth codec allows, and the higher the sampling rate, the better audio quality you are going to get, because you get the maximum available amount of information per a unit of time, which is constrained only by the bandwidth of Bluetooth. So if you're using a codec that will be prioritizing the sound quality and the amount of information passed in a single unit of time, you will be sacrificing the speed at which it's transmitted. So there's going to be latency introduced. But if you are going for I wouldn't say latency free, because it's never latency free, for a lower latency situation, then you will have worse audio quality because it needs to transfer the data quicker in order to get rid of latency.
What advancements have been made in Bluetooth codecs to improve compression efficiency?
So, in terms of advancements, over the years, there have been significant advancements in the Bluetooth codecs, enhancing both audio quality and the transmission reliability. So I'll go through a couple of them. So first of all, there are advanced compression algorithms that we mentioned today. So I would say most of the ones that we use, maybe except SBC, are quite advanced. They use more sophisticated algorithms to compress audio data. So these algorithms are designed to retain as much of the original audio quality as possible while reducing the file size for transmission. So then there is also higher audio resolution support. So again, newer codecs support higher audio resolutions. For instance, Sony's LDAC or Qualcomm's aptX HD offer a near high-resolution audio experience for Bluetooth. Again, it's a near, it's not a high resolution as per se, but it sounds all right. It sounds good. Then there's also adaptive bitrate. So some codecs like the aptX adaptive and Sony's LDAC dynamically adjust the bitrate based on the quality of the wireless connection. So this ensures a more stable audio transmission, especially when there are environments with potential interference. Then there's also improvements in terms of latency. So although Bluetooth has historically struggled a lot with latency, there has been an effort to reduce it in Bluetooth audio transmission. So again, this is vital for video viewing and gaming. And then codecs like aptX slow latency prioritize quick processing and transmission of audio data to minimize delay. Again, that comes at an expense of audio quality. Then there's also a thing that I have to mention definitely is the energy efficiency of Bluetooth codecs. So newer codecs are designed to be more energy efficient. So this is, again, crucial because most devices that use Bluetooth codecs, they're all battery powered. So by optimizing the compression and the decompression processes, these codecs consume much less power, and thus they extend the battery life of devices. So you're not going to have your phone die on you in the most horrible situations. Then there's also advances in error detection and correction methods that have made Bluetooth audio more reliable. So even in challenging wireless environments, these improvements help maintaining the audio quality by effectively handling data loss and interference. And the last but not least, integration of machine learning. So some recent developments involve using machine learning algorithms to optimize codec performance. So these algorithms can analyze audio content in real time and adjust the compression to maximize quality and efficiency.
Okay, you mentioned error correction.
Yes.
And maybe you could describe a real-world scenario where error correction actually becomes particularly vital in the Bluetooth audio transmission side.
Sure. So imagine you're working out at a busy gym, or GYM, as Homer Simpson used to call it. So you're working out and you're using your Bluetooth headphones and you're using your phone. So the problem here is that when you are using this setup in an environment like a gym, so the gym is filled with various electronic devices. So that can cause interference. So other people's smartphones, wireless fitness trackers, Wi-Fi routers, and whatnot, and even some like smart TVs use Bluetooth. So all of that might interfere with your music playback. So the role of error correction here, I'm going to go through several. First of all, the interference management. So in such an environment, the Bluetooth signal between your smartphone and earbuds is susceptible to interference from other devices because they operate on the same frequency band of 2.4 gigahertz. And error correction algorithms play a vital role here in ensuring that the audio doesn't break up or lose quality despite these interferences. Then also, as you move around the gym, some physical obstacles like workout equipment or even other people can disrupt Bluetooth signal because
but that's in case if you put the phone somewhere else, right? So you need to be between the end device and the thing, for example, your
yes,
phone.
definitely. Well,
then
it
these
happens,
physical things. Yeah,
Yeah,
it
yeah,
sometimes
it has-
happens, but I think mostly users are using it inside your pocket, right?
Yeah, that's true. But sometimes you forget the phone somewhere. Like there's been several times when I just realized that I forgot my phone because the Bluetooth was not working. Like it started, like I like
It's starting to chopping up and getting the lossy. You know, you're going away and like, oh wait, I forgot my phone. So that's actually a good indication that you forget your phone across somewhere else.
Yeah, exactly. There's a very good indication. So, yeah, error correction helps maintain the consistent audio, but again, to an extent, because when you get far enough, you will have packet losses anyway. So, also, this is a more like a end user experience, like how should I call it? You'll understand when I start talking about it. So, when you have a high intensity workout, for example, you expect a seamless audio. You don't want to pay attention. Oh, my audio is dropping out. What the hell is going on with my phone? There's glitches. There's dropouts. So effective error correction ensures that even if some data packets are lost or corrupted, they're quickly and efficiently reconstructed or retransmitted again, so the music stays uninterrupted. And also, one of the most unlikely, like I didn't know that was a thing as well, error correction, besides preserving audio quality, so in this scenario, for example, if we are talking about a gym, it needs to be energy efficient. So if you spend a considerable amount of time working out, you want your earbuds to last the entire session without needing a recharge. And advanced error correction methods balance the need for data integrity with energy conservation. So that ensures your device's battery life isn't drained as quickly by constant error correction processes. So for me, it was surprising because I thought that error correction is, because you have to retransmit information, like, well, not constantly, but I guess quite often, especially in these types of environments. So the fact that even this is energy efficient, I was like, oh, that's pretty cool. I did not know that.
For example, does the Bluetooth codecs uses like if they send you audio, right? So they're sending you audio from Bluetooth device from device to the Bluetooth. Do they use like one stream or there are several streams to compensate if some packets are lost? Because you mentioned restructuring.
Yes.
So how do they restructure these audio packets? If, for example, something is lost, will I hear it immediately, or will it be like error corrected? I won't hear that.
Yeah, if it's gonna be, if you hear it immediately, that means that the error correction did not do its job, basically.
Okay, so error correction comes in before I even hear it. So
yeah, definitely.
So and how does it have like a separate stream for that where it like sends additional packets to rebuild the audio, for example?
So if we're talking about the error correction process, first there is detection. So the first step is to detect errors in the transmitted data. This is usually done using algorithms that can identify inconsistencies or missing data in the received audio stream. Then there is the correction. So once an error is detected, the correction mechanisms start to kick in. So this could involve retransmitting decorrupted data or using algorithms to reconstruct the lost or corrupted information. So there's two types of error correction that at least I'm aware of from my research. There's FEC and ARQ. So FEC stands for forward error correction. So this method sends extra data, redundancy, along with the original data. So if some data gets lost or corrupted, the extra data can be used to reconstruct it. And then there is ARQ, which stands for automatic repeat request. So in this method, the receiver asks for the retransmission of data if an error is detected. So this is more common in data communications than in real-time audio due to latency constraints. So in audio, the FEC, so forward error correction, would be the one to go for.
If we're talking about real-world impact, how do different Bluetooth codecs affect the end-user experience in terms of audio quality and device compatibility?
Well, I guess here it all depends on the use case. So again, for example, if you're looking for a higher end sound, don't even go for Bluetooth. I'm jokes. If you're looking for a higher end sound, you would go for the highest tier Bluetooth codecs. So that would be the aptX HD or LDAC, because they're just better sounding. That would affect the user experience in terms of they give you the best sounding sound, the best sounding audio, but you trade your latency for it. If you're talking about user experience, for example, if the user is a gamer, then the sound quality is not the vital point here. The latency is the vital point here, and so that there is no, for example, audio dropouts as well. So you will sacrifice some audio quality for the latency. Again, it really depends on the end user, like who is using the Bluetooth device for what. But I would say that there is like these two ends of the spectrum. Well, I'll at least think always in these two ends of the spectrum, which is the quality audio and the latency, the low latency, no error, no dropout ones. Because as far as I remember, when I used the LDAC one, I had Sony headphones. Sometimes there were actually dropouts. You could hear like the audio just stops for a second, like abruptly, and just starts playing again. And just it's because the phone couldn't handle the amount of data that the LDAC, or it was the headphones that couldn't handle the amount of data that the LDAC codec was trying to transmit.
Maybe you could share more, like maybe any listener experience or feedback related to Bluetooth quality.
Well, yeah, I can share how I even found out that there's a difference. So I bought my first good pair of Bluetooth headphones, and I was listening to music on them for like months. And then I was like, let me try to connect a wire to them and to my phone. And I was like, wow, there is a big difference. Like, why do they sound so bad on Bluetooth? And why do they sound so good at wired? And then I realized, there's different codecs. What are those? So I went into my phone and I had the SBC, so the standard lowest quality one. I put the aptX on and was like, this is almost as good as the wired one. And the thing is also, when you're listening on your phone, phones used to have these mini jacks. Now they don't. Most of them at least don't.
3.5 or something like that.
Yeah, 3.5 millimeter mini jacks.
Yeah,
exactly.
But now they just fully remoted. But actually, it's quite nice. You can still buy adapter, right, from USB-C or Lightning to 3.5 and use the old school earbuds.
Yeah, that's true. But like in my opinion, one dongle is one dongle too much. Like,
True.
I prefer when I can just use the. But like honestly, why I don't really care that much about those wired connections in phones, for example. When you have a 3.5 millimeter jack in a phone, that jack is connected to an amplifier. So a phone has an amplifier. Every phone has an amplifier because it needs to drive your headphones in order to produce sound. And usually, amplifiers in phones are not that great. So you're not going to hear a great deal of difference between, for example, a higher tier Bluetooth codec and a phone amplifier if you plug it in the phone, because the amplifier, if you're using more than like standard headphones, like at least some sort of decent headphones, they need a decent amplifier to sound the best they can. If you just plug them into the phone, it's going to sound all right, but it's not going to be like there's a massive difference between the Bluetooth connection and the wired connection.
Is there any difference, for example, if you buy headphones with audio card as well? Because some of the, I'm not sure if that's not true. Now, a lot of headphones have that, but like 5 or 6 years ago, there was possibility to buy like USB type headphones with audio card in it, and it was like really, really well. So does that impact somehow the end user experience as well?
I would say yes, because first of all, then that means if they have their own audio card, that means that there's some onboard processing going on that is tailored specifically for those headphones. So there's no room for error there, so to say. In terms of you can get headphones that require an amplifier, you can get an amplifier. But like the combination of those two, because of some characteristics, some things, some nuances, is not going to be great. But if you're getting a full complex that maybe you can't even disconnect it. Like in terms of audio card, I actually don't know what you mean exactly. but like I can make an
You can
educated
try
guess.
to look up Steel
What are they called?
Series. Steel Series had Siberia V2. It's pretty old ones. They had audio card. I think Steel Series is still
I
like
used to own these.
creating.
Yeah, I
Yeah,
used to own
and
these.
I think Steel Series still are creating the audio card type of headphones.
Okay, I
So
see.
they have like a gaming headset as well for the wireless types,
Mm-hmm.
and they have like a dock separated where you actually can connect. And they're saying that they have a really low latency, and a lot of
Mm-hmm.
gamers actually I think use that. Of course, they're pretty expensive, around
Yeah.
400 or something like that, but they're really I think worth it. But yeah, it was in my good old days when I was playing Counter-Strike. It was my go-to headphones, like Siberia versus V2, and they had this special edition with Frost Blue, like, and they had the
Yeah.
audio card. It was amazing,
Yeah, damn, I
and
forgot I owned a pair of these back in the day. I
yeah,
really did.
and they were really nice, and they gave this crisp audio, and of course, they didn't have a lot of bass to it.
Yeah.
It wasn't made for like Spotify listening. And back in the day, the
Yeah.
Spotify, I'm not sure if even that existed. But for gaming, it was like you could hear some steps that you couldn't hear even on other audio headphones.
Yeah, well, I would
yeah.
I would make an educated guess that it's not only related to the inbuilt onboard processing, but also a lot of that is dependent on the drivers. So the actual physical the coils and the magnets that produce the sound, because and of course the interplay between the onboard processing and these drivers. That's why I said it has definitely benefits because it's all fine tuned to work together. It's like one ecosystem. There was also one thing that you mentioned about bass that I wanted to share. A lot of bass is dangerous for your ears, and let me explain why.
Okay.
Just a heads up. When you hear loud, high frequencies, it hurts your ears. You can feel it in your head. You can feel like people when you scratch a chalkboard or you use a knife on whatever. These frequencies are painful. They're audible and they're painful. Bass does not hurt your ears, but it damages your hearing as much as the high frequencies. So it's very tricky and dangerous in terms of you're not going to feel physical pain from too much bass, but it's dangerous because it will damage your hearing over time. So and also there's this thing when you're using a set of headphones with a sound signature that has, for example, a lot of bass, your ears really get used to that. And then when you put headphones with more like a flat response, you're like, there's no bass, there's zero bass. But if you give yourself a week in those headphones and then you listen to the bassy ones, you'll be like, what the hell is this? I'm being drowned in bass. So just a heads up, you have to be careful with extremely bassy headphones. You can damage your hearing without knowing it.
Wow. And how about if we're talking about damaging the ears?
Yes.
Is it better to have earbuds like these or overhead phones or like even like in-ear AirPods? Maybe answer to this question as well.
I would say that the number one factor in terms of damaging ears is listening to things loudly. And for example, I'm sort of lucky. I have very sensitive ears. I don't usually go above like 60% of volume on any headphones. Is way too much for me. But if we're talking about the comparison between the in-ear and the over-ear ones, I would go for the over-ear ones with active noise cancellation, because active noise cancellation enables you to listen to things at lower volumes. You don't have these sounds, the ambient sounds coming in and like making, I can hear my music, I need to turn it up, and then you end up with a much higher volume than you probably could have listened to it. So I would say,
because you try to add a volume up so you don't hear the noises from outside, but if you have noise cancellation, you can actually turn it down. That's smart.
Exactly. Yeah. So I would say going with an over-ear set of headphones with active noise cancellation. But also you have to be careful because some of the modern noise cancellation is so good, you're not going to hear a car honking when you're crossing the road. So you need to be careful with that.
That's good in a sentence and also bad at the same time.
Exactly.
So yeah, I think It was a quite insightful explanation from you, right?
Thank you.
I'm really thankful for having you in this podcast, and big thanks to you, Esam, that you had the time and found time to join us from TestDevLab for this technical deep dive into Bluetooth codecs today.
Yeah, sure, my pleasure.
I hope we both, not only we, but also our listeners learned a lot, and I hope you have listened till the end and liked it. And for everyone that listening it, we appreciate that you tuned in. If you like what you heard, subscribe to Tech Effect series on Spotify, on YouTube if you want. Also, we're always keen to hear from you. So feel free to leave a review and feel free to send us comments and your thoughts on all the topics that we had previously, and also the Bluetooth technology through our social media. We'd be happy to answer these questions. And stay tuned for our next episode for much more tech insights. Until then, let's keep enjoying your wireless world. And thanks for listening, and see you next time on Tech Effect.
Bye.